All right, we're moving on to intercepts on a graph. An intercept is where a graph or a point touches the axis or crosses the axis of a coordinate plane. The x-intercept is where a graph crosses the x-axis, and very important to note that the x-intercept is when y equals 0, and we'll get more into this on the next slide. The y-intercept is where a graph crosses the y-axis, and also important to note is the y-intercept is when x equals 0. And I'll point this out why that is on the next slide. So here we have a linear graph. We know it's linear because it is a line on this coordinate plane. And we could see that this graph, if we look for the x-intercepts, that's where it crosses the x-axis. So just as a reminder, the side to side is our x. If I can make an x, apparently I cannot. Let's try this again. Okay, this side to side is our x, and then the up and down is our y. Okay, so if we're looking for the x-axis, we're looking for where it crosses, or the x-intercept, we're looking for where it crosses the x line. We could see that it crosses right about here. And so if we were to write the x-intercept as a point, then we would write it as 3, 0, because we go side to side 3 and up and down 0. Now, remember what I said, that the x-intercept is when y equals 0, and we can see that here y does equal 0 because it went up and down none. If it did go up and down at this point, then it would not be touching the x-axis. So that's why the y is equal to 0. Now, if we're looking for the y-axis, or the y-intercept, that is where the graph crosses the y-axis. So we can see that it crosses y right here. And if we were to write that as the y-intercept as a point, then it would be 0 because we go side to side 0, 5 because we go up 5. Now, just a reminder that in the first slide I had mentioned that the y-intercept is when x equals 0, and here we can see that x is 0 because if you were off of x0, you would not be crossing the y-axis. So we're going to do another example on the next slide. Here we have a new line, and we're looking for the x-intercept. The x-intercept is where the line crosses the x-axis. And so we can see this is our x-axis, and we see that it's crossing here. So the x-intercept is -6. If we were to write that as a point, x-intercept, then we go side to side first. It goes back 6, so we have -6. That's a negative there, okay. And then we can also see that we go up and down at that point 0. So our x-intercept as a point is -6, 0. Now if we're looking for our y-intercept, that's where it crosses the y-axis. And if we're looking, we can see this is our y-axis, and the line is crossing the y-axis right here at that 4. If we were to write this as a point, our y-intercept, we would be writing 0 because it goes side to side 0 at that point, 4 because it goes up 4 at that point. All right, in this next example, we have another line. So first thing we're going to do is we want to look for our x-intercept. Again, the x-intercept is where this is crossing the x-axis. And so we're looking at the side-to-side axis here, and we can see that crosses at this point right there. Our x-intercept is -10. If we were to write that as a point, then we would be writing -10, again, 0, because we're going up and down 0. And then if we're looking for our y-intercept, then we're looking for where it crosses the up and down, y to the sky, and it's crossing the y right here, which is -7. So if we were to write the y-intercept as a point, we would have 0 because it's going side to side 0, -7 because it's going down 7. Another example here. This time, if we're looking for our x-intercepts, that's the side to side, we see that it's crossing right here. So that means that our x-intercept is 0. If we were to write that as a point, then we would write it as 0, 0, because it's going up and down 0, side to side 0. And if we're looking for the y-intercept, it's actually at that same point, because we're looking at the up and down here, and we notice that it crosses right at that same point. So the y-intercept is also 0, 0. And just a reminder that that 0, 0 point is called the origin of the graph. Origin, that's going to be important for you to know. Now in this next example, we have a horizontal line, horizontal side to side. So if we're looking for an x-intercept going across this way, there is no x-intercept. So you can write DNE, which stands for does not exist. So the x-intercept does not exist, DNE. Now if we're looking for the y-intercept, that's where it crosses the side to side, and that is right here at this -5. So if we were to write the y-intercept as a point, then we would write it as 0 because we're going side to side 0, -5 because we're going down 5. We have one more example here. In this case, it's a vertical line, vertical being up and down. In this case, we're looking for the x-intercept where it crosses the x-axis, crosses the x-axis right here, if I could get a point there, at 2. So if we were to write the x-intercept as a point, then it would be 2 because we go side to side 2, 0 because we up and down 0. And now we're looking for the y-intercept where it crosses the y line. We're looking here, and it does not cross the y line. So just like we did in the last example with the x-intercept does not exist, for y-intercept we're just going to put that same DNE, which stands for does not exist.